Every compass on Earth is slowly going out of date. The magnetic North Pole is drifting toward Siberia, faster than ever recorded. Here's the strange part. Our planet's magnetic poles have completely traded places, many times throughout Earth's history. And one day, they will do it again. When that day comes, North becomes South, South becomes North, and everything from satellites to sea turtles feels the change. The last full reversal happened 780,000 years ago. Which means, statistically, we might be overdue. So what would actually happen if Earth's magnetic poles flipped in our lifetime? Here are 7 things science says to expect. Some of them are alarming. One is strangely beautiful. And the last one changes how you'll think about this forever. Thing number 1. Every compass on Earth becomes a liar. Needles that pointed north for centuries would slowly swing toward chaos. During a reversal, and the what you've dettering close up, the field doesn't just flip cleanly, it breaks into patches, with multiple north and south poles wandering the globe. Imagine a compass in New York pointing east, while one in London points somewhere over Africa. Navigation as we know it unravels. Ships and planes wouldn't be lost, though. GPS doesn't depend on magnetism. But every backup system that does would need rewriting. Airports would literally have to rename their runways, because runway numbers are based on compass bearings. All of them. Every 5 years, scientists update the World Magnetic Model, the invisible map that keeps your phone's compass honest. They'd be rewriting it constantly. Sailors have handled a slowly moving magnetic north for centuries. But nobody has ever navigated a world with 6 of them. And that's just the beginning. Because humans aren't the only ones who trust the magnetic field. Thing number 2, the great animal confusion. Billions of creatures navigate using an inner compass we still barely understand. Sea turtles cross entire oceans and return to the exact beach where they hatched, reading the magnetic field like a map. Migrating birds sense magnetic lines through special proteins in their eyes. Some scientists think they literally see the field. Whales, salmon, monarch butterflies, even honeybees, all of them steer by the planet's invisible grid. Racing pigeons already get lost during solar storms, when the field wobbles for just a few hours. Now imagine years of wobble. Many animals carry tiny crystals of magnetite inside their bodies. Actual compass needles, grown into living tissue. During a slow, messy reversal, their maps would shift year after year. Some populations would wander far off course. The good news? Past reversals didn't cause mass extinctions. Life adapted, generation by generation, and relearned the sky. Thing number 3. Our planet's shield drops to 10% power. This is the one that worries scientists the most. During a reversal, the magnetic field doesn't disappear, but it weakens dramatically while the poles fight for position. A weaker field means more cosmic radiation and solar particles slipping through, especially for satellites and astronauts. We've seen a preview of this. There's already a weak spot over the South Atlantic where satellites shut down as they pass. With the whole field weakened, every orbit becomes that anomaly. Spacecraft would need heavy shielding just to survive. Airlines already reroute polar flights during strong solar activity to protect crews from radiation. A weak field would make that routine everywhere. For astronauts, a reversal era would mean thicker shielding, shorter missions, and careful timing around every solar storm. Down here, the atmosphere would still protect us from the worst of it. But the sky itself would start to change. Thing number 4. Auroras over the equator. The one apocalypse symptom that looks like a gift. Auroras happen where magnetic field lines funnel solar particles into the atmosphere. Today, that only happens near the pole. But with multiple wandering poles scattered across the planet, those glowing curtains would follow them everywhere. Green and crimson lights over the Amazon. Purple ribbons above the Sahara. Cities that never saw an aurora would live under them. Only the strongest storms push auroras to the tropics today. In 1859, people in Cuba and Hawaii watched the sky burn red. during a reversal that once-in-a-century sky could become an ordinary Tuesday night. During the Lachamps event 42,000 years ago, auroras may have danced near the equator for centuries. It would be the most beautiful warning sign in human history, because behind the light show, our technology would be struggling. Thing number 5, the trillion-dollar tech problem. Our civilization runs on systems that assume a stable magnetic field. With a weakened shield, ordinary solar storms would hit like historic ones. And historic ones were terrifying. In 1859, the Carrington event set telegraph offices sparking. Today, a storm like that could damage power grids for months. Satellites would age faster, bombarded by radiation. GPS accuracy would wobble. Long power lines would carry dangerous currents. Even internet has a weak point. The long undersea cables linking continents can be disrupted by strong geomagnetic currents. Economists estimate a single extreme solar storm could cause trillions in damage. A weak shield multiplies those odds every year. None of this is unsolvable. Engineers already harden satellites and grids against space weather. A flip would just raise the stakes. The real question is time. How fast does a reversal actually happen? That's thing number 6, and it surprises everyone. Thing number 6. The flip is not a switch. Forget the disaster movies where the poles swap overnight. Rock records show a full reversal takes somewhere between 1,000 and 10,000 years to complete. High-fitted filiches of Arcudian. Ancient lava flows captured the process like snapshots. As they cooled, their minerals froze the field's direction in stone. The seafloor keeps the full diary. New crust spread from regions records every flip in stripes, like a barcode of Earth's history. Sometimes the field starts to flip, then changes its mind. Scientists call these excursions, half-finished reversals that snap back. Those records tell us the field weakens, splinters into wandering mini-poles, stumbles through centuries of confusion, then settles. A person born during a reversal would never notice it happening. Their grandchildren wouldn't either. It's not an apocalypse, it's a renovation. Slow, messy, and survivable. Which brings us to the last thing, the big one. Thing number 7. We already survived one. And we did it without a single satellite, power grid, or weather forecast. 42,000 years ago, during the Lachamps excursion, the field collapsed to a few percent of its normal strength. Early humans lived straight through it. Some researchers even link that era's cave art to people sheltering more. It's debated, but fascinating. Mammoths, Neanderthals, our ancestors. The fossil record shows no mass die-off tied to the field's collapse. Birds, whales, and turtles are descendants of survivors. Their ancestors navigated through hundreds of reversals and kept migrating. And unlike animals, we upgrade fast. Our technology reinvents itself every decade. The field takes centuries to change at all. Life on Earth has now survived at least 180 magnetic reversals. Every single one, without exception. So a flip is not the end of the world. It's a challenge for our technology, not for life itself. Which brings us to the question you're probably asking. Is the flip starting right now? The field has weakened around 9% in the last 2 centuries. And that dent over the South Atlantic keeps growing. But scientists who reconstructed thousands of years of field history say this looks like a fluctuation, not the start of a flip. Even if a reversal began tomorrow, your compass would still work, your phone would still work, and sunrise would look the same. Our species would have centuries to prepare, hardening satellites, upgrading grids, and watching the greatest light show ever. So keep your compass, it has a few good centuries left. And if you want to see the dent that started all this, watch this video next.